Manipulating graphs of functions. Using the same transformation properties as we used before, we will take key points of the graph and move them to create the new graph of the function. So we have to recall all of those transformations, the translations, the stretches and compressions, and the reflections. All those we got to remember what they do, because now we're going to do them with the graph. So there's a three-step process to actually creating the new graph. Step 1 is to start by graphing the parent function, which we learned in the very first video how to graph the parent functions. Okay, so start with the parent function. Then we mark any key points and or asymptotes. Remember, asymptotes are lines that approach, or the graph that approaches the line but never touches that line. That's the asymptote line. Okay, so mark any of those on the parent function. Lots of times that'll be the origin and maybe, the point 1, 1 sometimes. So we mark a few of these major points that we can easily move, and then we're going to, for step 3, take those points and asymptotes and actually shift them around wherever they need to be. Okay, so these 3 steps will create the new function. So now we're going to do some examples on how to actually do this. Okay, so in this first one, we have negative log base 10, so just the regular logarithmic function, x plus 3 plus 2. Alright, so my parent function is just log base 10 of x. Okay, so I'm going to graph that. So I know it goes through 1, 0 right there, and it comes down, and then it kind of curves up like this. So that's my log function. So that's my parent function. So I'm going to mark that. Alright, now I'm going to find any key things about it. So some key points would be, there's an asymptote line right here, because it's going to approach there, but it's never actually going to reach there. So I'm going to mark that. And another key point is this point 1, 0. So I'm going to mark that. So I'm going to move those 2 parts to get my new function. So the first thing I notice is this negative right here. So it is a negative on the outside of the entire function. So that would be a negative changing the y. So if it's changing the y, I need to flip it over the x. So my asymptote won't change, but I'm going to curve this way. Alright, and then it's going to curve out here. Alright, so now I've reflected it over the x. Okay, so that was the first thing. And now it looks like the only other things that we have to do is move it plus 3, which would be left 3, and plus 2 on the outside, up 2. So I'm going to move this. I'm going to move my point 1, 0, because it didn't change. So I'm going to move it left 3, 1, 2, 3, and up 2. So that is my point. It was 1, 0, and that means my asymptote is going to move the same distance. So my asymptote is going to be here, and I'm transforming that green one, so there's my final graph after the translations. Okay, so now I've done everything to it, so this blue graph is my final graph. So you should sketch maybe several graphs on each graph, but then indicate which one is your final graph. On this next one, I have g of x equals e to the power of x minus 3 minus 1. So my parent function is going to be e to the power of x. You can't just write nothing to the x power, because it's got to have something. It's got to have a base. Give it a base. Alright, so now I'm going to graph my parent function. It's going to go through 1, 0, 0, 1, my bad, and it actually has an asymptote. Graphing that parent function has an asymptote at the x-axis, so it's going to look something like that. So that's my parent function. Alright, now, as I look at this one has no flipping, no stretching, no anything like that. So all I have to do is shift it around. So I'm going to shift it. I'm going to look for my key points, so the point 0, 1, and I have an asymptote right here, so I'm going to mark that because this line's never going to be crossed. And I'm going to go, it looks like -3 inside with the x means I'm going to go right 3. And then -1 on the outside means I'm going to go down 1. So that's going to be the point 0, 1. But my asymptote has to also move as well. So there's my point 0, 1, and my asymptote is actually going to move down 1 as well, because if it's got to be in the same relation to the point that we just did. So there we go. And there's my final graph. Okay, in this next example, it looks like we have h of x equals 2 times the square root of -x plus 1. Okay, so if I get rid of all the extra things, then my parent function is just going to be the square root of x. Alright, so I'm going to start by sketching that. So my parent function is going to go through 0, 0, 1, 1, 4, 2, and so on. So there's my parent function, so I'm going to mark that. Alright, and now I need to figure out all my shifting. So the first thing that I'm going to shift is, it looks like I have a times 2 on the outside of everything. Alright, so I'm going to start by stretching it vertically by 2. So that means everything is going to stretch up. So instead of it being 1, it's going to be 2. Instead of it being 2, it's going to be 4. Instead of it being 3, it's going to be 6. So just multiply all of those y's by 2. Okay, so then I'm going to sketch that. So that would be after the stretch, the vertical stretch of 2. So that would be that green one right there. Alright, and then the next one, it looks like we have to do our negative right here. So there's a negative inside with the x. So a negative in with the x means we're changing our x as a reflection. So it's going to flip over the y-axis. So I'm just going to take those points that are marked here and just flip them over the y-axis. Alright, so it's going to look something like that. Okay, and now the last part, we have this plus 1 on the outside, so that's going to take it up 1. So now I'm going to take all those points, and I'm going to shift all of the points up 1. So there's up 1, this one would move that up 1, and then up 1, and up 1, so then I'm just going to connect those. So the white is my final graph. Alright, didn't really hit that, but that's the idea. So that's how we would graph it. And then my final graph is just the white. It doesn't go any past right there. There's your final answer. That's it for your notes on manipulating graphs of functions. Go through the practice problems. Make sure that you can do this when you are given everything in standard form, and then prepare for your quiz over the material.